Now you have combustion. After combustion you have to remove the gas. Okay, so several technical terms are there. So engine scavenging, one term is there. So PV diagram, if you remember, 1 2 3 4. Okay, so this is 4. Okay, so 3 to 4 expansion happening and you got lots of power. After power you have to remove the gas. This is called scavenging operation. Okay, this is called scavenging. So purging of combustion chamber of exhaust gases and replacing them with fresh mixture of air and fuel. So basically this term is for 2-stroke engine. 4-stroke engine we have separate stroke for inlet and exhaust. Okay, 4-stroke engine you can remember we discussed like this. Okay, 1 2 3 4 5 6. Okay, so 2 idle strokes are there, 1 to 5, 5 to 6. These 2 idle strokes, one will be removing all the burned gas, and when piston is moving towards, this is BDC, TDC, TDC to BDC, it will take intake air, then it will compress. Okay, but in 2-stroke engine you don't have separate that idle stroke. This is called idle strokes. Okay, it is doing some work but they are terming as a idle stroke. Okay, it is just sleeping. Scavenging is particularly relevant to 2-stroke engine purpose, removing burning gases from the combustion chamber after power stroke, and you are taking fresh air. Okay, now supercharging. So supercharging means compressing air before it enters the engine combustion chamber. What happens in at the point 2, you need sufficient amount of air. Okay, air fuel ratio, you see this certain amount of fuel you take, it will take certain amount of air. Okay, but let's say you are trying to design a compact engine. In compact engine you need more amount of fuel because small engine, but you need very high power. So in that case, what you do, you give more fuel. More fuel means you need more oxygen. More oxygen means how to give more oxygen at 1 atmosphere pressure, fixed amount of oxygen you can get. So you compress it, so you give more oxygen. Air whatever you are getting, that will be mixed with basically nitrogen and oxygen. Okay, and if you compress it, then nitrogen amount also increasing but oxygen amount also increasing. Okay, so that will be helping to get more power. Okay, and air compressor known as supercharger, it will be helping you. Okay, it will be compressing air, then you after compression you are injecting into a cylinder. Okay, so pressure will be higher than normal atmospheric pressure, so this is called supercharging. The normal charging, if you say only the charging term means you are giving air. But supercharging, when you are saying super word, because of super word actually you are compressing, then you are injecting. Okay, another term is turbocharging. Turbocharging means you are using compressor, but compressor will be run by your exhaust gas. How? Similar to supercharging, but instead of mechanically driven compressor, it uses turbine driven by exhaust gas. So exhaust gas rotate turbine that will be connected to compressor, then compressor will be compressing air that will be injected to your cylinder. So it is not asking you to give extra power, rather exhaust gas is certain amount of energy, so that energy you are using to run your compression system and you are using for your engine. Okay, especially for big engines, marine engine or industrial engines, so there you can do this one. But for a small engine from a bike or car, normally you will not think about turbocharging. Maybe you will have electrical or other systems, so that will be okay. Okay, so turbocharger, how does it work? Like say you have one engine. Okay, I have one piston, crank. Okay, so it will be rotating and my piston is here. Now exhaust gas whatever we are getting, I'll be putting into a compression system. Compressor will be connected to your turbine system. Okay, so it will be going through one turbine, this exhaust gas. So turbine will be rotating, turbine will be rotating turbine blades, it will be transferring that power to your compressor. This is turbine. This is compressor. This is called gas turbine system. Later we will discuss about details about gas turbine system. Presently just remember this is one turbine system. Okay, turbine compressor system, and it will take fresh air. Then compression will be happening. Compression will be happening. After compression you are cooling. Okay, then cooled air you are transferring to your engine. Okay, this is inlet. And cooling will be done using seawater. Okay, because seawater is available, so you are using a cooling the system using seawater. So compressed air. So in this case you can see we are not using any extra energy to run compressor, rather compressor is driven by turbine. Turbine is getting power from your exhaust gas. Exhaust gas is having higher temperature, higher pressure also, so that is running my turbine, small compact turbine. Okay, and turbine and compressor is specifically drawn certain way. So later when we will discuss about gas turbine, so I'll explain why I have drawn like this. Okay, presently just you remember this is one turbine compressor system. Maybe you can make a block. This is called turbocharger. Okay. Now spark plug. I have shown you one small spark plug I think last day. So that spark plug should be initiating the combustion process. Okay, so you can see this auto cycle 1, 2, 3, 4 PV. So nearby 2 spark will be created. Spark will be created immediately within microsecond. The high energy will be transferred in the whole cylinder and whole thing will be burnt together. Okay, so it is initiating. Okay, after that automatically because of released heat whole thing will be burnt. Produced an electric spark that ignites the compressed air fuel mixture. Air fuel mixture, it is temperature already high, then you are giving spark, so then immediately combustion will be occurring. Okay, it consists of metal shell, an insulator, central electrode and a ground electrode. Okay, it will be like this. Okay, so thread will be there, then okay, so thread, just to fix it, thread and insulator nose. Then electrode is here, or central electrode, and this is called ground electrode. So you can see this right side animation GIF picture. You see this suddenly press your spark, that electric start, immediately there will be small spark. The small spark will be generating lots of heat. That heat will be burning nearby air and fuel molecules. Okay, reaction will be happening, so that will be releasing further heat. That heat will be transferred to other molecules, then whole cylinder inside whatever fluid is there, mixture of air and fuel will be burned. Okay, over time the electrode of a spark plug can wear due to repeated sparking and exposure to high temperature. The gap between central and ground electrode determines the spark plug's firing ability. Okay, so this gap also you cannot keep whatever you like. Okay, so you have to keep within like 0.6 millimeter to 1 or 2 millimeter gap maximum possible. Okay, so then you will create very high energy spark, so that energy will be helping you to initiate combustion. Not during whole combustion is not required, only initiation is required. Gap is 0.6 to 1.68 meter, 0.6 to 1.8 millimeter. Okay, gap, GAP gap. And spark, okay, heat 500 to 85 degrees centigrade, okay, for passenger car. So just you can get roughly the idea, 500 to 85 degrees centigrade temperature you are producing, okay. So that will be burning your fuel air mixture. There's some more thing. Okay, let's see. Carburetor. So carburetor, I told you that it is used to mix air and fuel. Okay, so it regulates, mixes air and fuel for combustion. The primary fuel delivery method is through the venturi tube with additional component providing extra fuel or air as needed. Okay, so it is like this. It will have one venturi like this. Okay, then one pipe will be coming from a chamber. Okay, chamber will have oil, gasoline or fuel. Oil means it will be confusing. Sometime lubricating oil will be called as oil. So rather we'll write fuel and lubricating oil separately. Okay, one needle valve will be there. Needle valve, and one float is there. So float will be controlling how much fluid is there inside chamber. Now we'll have one throttle. And there will be another choke. Air will be entering. Okay, so air is coming through this small restricted path, and because of restricted path your pressure will be down. Why? Because if you see P Bernoulli's equation, P pressure and velocity, flow rate will be same, but velocity and pressure inversely proportional. Okay, so if you are changing velocity, because you are restricting that area of tube, so velocity will be increasing. Velocity increasing means pressure will be down. Okay, when pressure is down, so that pressure will be sucking the fuel, and when fuel will be sucked, it will be mixed up. Okay, that mixed up fluid will go to your engine cylinder. Okay, this is a piston, again I am saying. Okay, so this is basically the simple carburetor diagram. Simple of a spelling carburetor. I think British American is spelling different. TER also there, single T also there. Okay, so what is happening in carburetor? Carburetor, actually you are creating one restriction. So restriction means you are increasing fluid velocity. Okay, you are initially pipe diameter uniform, certain area you are reducing pipe diameter, so there you have to maintain same flow rate or mass flow rate. Then fluid velocity will increase. When velocity increase, pressure will be dropping. So that pressure dropping area, you put fuel injection pipe. Okay, so that fuel will be sucked, it will mix up with air. So that mixed thing you inject into your cylinder. Okay, so that way the carburetor will be working.